All right, welcome Year 10s to episode 4. Today we're going to learn about prisms and how to calculate volumes of prisms. And then we're going to do a little bit of converting units of volume, which is just the next level up from area, but it's the same sort of principle. So if you understood how that worked, then you can understand how converting volumes will work. All right, without further ado, I'm going to get into these problems because if we can solve these problems, we are 80% of the way to solving the volume problems for prisms. So, if you would like, you could go ahead and solve these problems yourself. If you're feeling confident, just put me on mute and see if you can get them done before I get them done. I just read Williams' thing, do a pose for the thumbnail. Maybe next time, William. I should have like a thing that I say every time to help you guys get interested. All right, rectangle area, very easy. You just multiply your two numbers together. So if we're getting the area of this, then that's going to be 200 times 150, and which is going to equal, well, 2 times 15 is 30, and then we got 3 zeros to tag on the end. 30,000 kilometers squared. It's a pretty big area. It'll be like the size of Canterbury, I reckon. Roughly. All right. Moving on. Parallelograms. Very easy. Almost the same method of working out these problems. Because, you know, if you trimmed off this bit and stuck it over there, then you've got a rectangle. So you just do 5. Area of parallelogram equals 5 times 6, which equals 30. And the units that we're looking for are meters squared. All right. Sorry about that. That was probably quite jarring. Let's get rid of that. Okay, we have been given a diameter this time. So, but you will know this formula off by heart now. Area equals pi radius squared, not diameter. Now I'm going to show you how you can change the formula into a formula with diameter in it. But of course you could just diameter equals 24, so radius equals 12. That's great. But sometimes you just don't. You want to have it all included and just go straight to a formula. So how would we even make that formula for diameter? So, well, we need the other formula. So diameter equals 2 times radius. But we want to sub in something for just r. So diameter divided by 2 equals r is what we're going to drop into our formula. So area equals pi times diameter over 2 squared. All right. Now, you might remember back to our indices. This is why I wanted to do this, is because when we had our indices, we had everything inside this bracket gets squared. So our final formula is area equals D, so D gets squared, and divided by 2 gets squared, so we actually divide by 4. 2 squared is 4. So this formula, area equals pi D squared over 4, that's the same formula as pi R squared. Seeing as we've got a new formula, let's use it. So pi times 24 squared divided by 4 equals, I haven't got my calculator ready. That over. Okay. Shift pi times 24 squared divided by 4. We don't want our answer in pi, we want it as a decimal. 452.4. And that would be 452.4. 452.4 centimeters squared, and that was 4 significant figures. Generally, 4 significant figures is accurate enough for most things you do in life. You're talking, you might get errors of 0.1% by using 4 significant figures. I think less than that actually, probably 0.1%. Oh yeah, we're going to forget about perimeter today. Sorry about that. I just raced into it and didn't really make any specific questions. I guess you could find the perimeter for all of those. It would actually be pretty hard for this one because there's no angle in there. Anyway, let's get onto this one. I chose this shape because isosceles triangles have certain properties. So the first one is this line here means that that side is equal length to the other side. So this side on the far side of the triangle is also 8 meters. So our perimeter is going to be 8 plus 8 plus 6 would be 22 meters. We want to work out the area. So we want to know the height of this triangle, right? Because once we know the height, we've got the base, we can do half base times height to get our area. All right. Now, with an isosceles triangle, you'll notice that we have divided it in half, and we've got 2 right-angle triangles. And when we've got right-angle triangles, we can use Pythagoras. So if we peel away one right-angle triangle, we have 3 meters here, and we have 8 meters here. So we've got our remaining height here. Okay, so we're doing a short side Pythagoras problem. So when you're doing a short side, you're doing the subtraction one. So we've got our 8 squared minus 3 squared. And that's because we're doing short side. We've got a minus there. All right, let's chuck that into our calculator, see what we get. 8 squared minus 3 squared. All under the bracket gives us square root of 55, which is 7.416. 7.416. I don't know why I did that in blue pen. I guess I should be doing everything in blue pen. 4 significant figures. And that distance is in meters. Okay. All right, we're not done. We need to find the area. So back to here, this is our base. We found our height, so we're going to go area equals half base times height. I like to use 0.5 in my calculator, so I'll just write that in, times a base of 6 meters times 7.416 meters. Let's chuck that in the calculator. Done that well, Mr. Dilly. Squeezed it all in. Times 6 times 7.416. 22.25, because we'll round that last digit up. 22.25. 22.25 meters squared, because we're dealing with area of a triangle. Okay, moving on. Prism time. So cover your ears, turn down your volume, because I'm going to do a lot of tapping now. I'm going to write out basically what a prism is. A prism is an object where a front face has been extruded. So what we have here, we have a front face and it's been extruded in the 3 into the 3rd dimension, the Z direction. So that's what I mean by extruded. So the front, something's got a front face and it's just been pulled. Okay, so with the cylinder, we got a front face and it's pulled. I wonder if I can just use one of these pins. So that's gonna get rid of that. So that distance, 32 meters, is the same all the way around that circle. And it's, if you cut it anywhere in the circle, you'd get you'd get the circle. It'd be the same circle. So that's different from well, it's not different. So a cylinder is actually a prism, a cylindrical prism. But usually we just say cylinder. And a box is basically a rectangular prism. So box is a rectangular prism, and a cylinder is a cylindrical prism. They all have the same rule. So this is a triangular prism. Okay, so anything that has a front face that has been extruded is a prism. Okay, so to work out, I'll just do a little, I might just pull all that up a bit so I can get in a formula. So the formula for the volume of a prism is just the area of the face times by the what would you call the length? So we know how to do the area of all these face shapes now. So we just need to multiply by our length, and we've got our so the area of the face, and then multiply by the length, right? Okay. Let's do the first problem. So the box, I actually was using this box. So this was going to be my new headphones, but unfortunately, I don't have the connection for those headphones. So I went and got some Bluetooth ones that are going to be real nice, and I can play games with those. And yeah, but I had to spend a little bit more extra money than these cheap ones that don't even have the right connection. But anyway, that box has about these dimensions: 12 centimeters by 5 centimeters by 14 centimeters. So let's work out the volume of this box. The box equals 5 times 12 times 14. So that's the volume of the face, and then that's the volume, that's the area of the face, and that's the length that it's been extruded. So let's put that into a calculator. 5 times 12 times 14, 840. It's simple, 840. Now units, I should have done centimeters cubed, because we've multiplied centimeters by centimeters by centimeters. With centimeters have been multiplied together 3 times. So you get centimeters cubed. Okay, let's move on to the squashed box, or the parallelogram. So I've basically taken the same measurements, but you can think of a parallelogram prism is like a squashed box. So if I had this same box and I sat on it and it squashed it, and now it's only 4 centimeters high, you can see how by doing this problem we can show how the volume changes from something, because this would have the same dimensions, but it's just been squashed, so the volume is going to be probably smaller, right? But anyway, we've still got to work out the area of the face and then multiply it by the length that we extruded. So volume of the SB, the squashed box, equals 4 centimeters times 12 centimeters times 14 centimeters. So this is the area of our front face, and then this is the area that we extruded. So if we put that into our calculator, we're going to get 4 times 12 times 14 equals 672 centimeters squared. So you can see that the shape of a box, even though it's got the same lengths on each side, if you were to squash it, it would reduce the volume. So basically, a rectangular box is the most efficient use of the volume. So when you're designing a product, don't do parallelograms because it's not using your materials efficiently. So you would say that the surface areas, we might do it, area would be the same for those boxes, but the volume changes. Okay, the cylinder. So in this question, we've got different units. We've got centimeters and we've got meters. I know I always tell you to go into meters, but I think in this case we would get a bit of a nasty decimal, so we'll avoid using it. Also important to note is that a centimeter cubed, 1 centimeter cubed is equal to 1 milliliter. So I mean, you can do conversions between meters cubed and liters, but this is a really astounding connection between milliliters and centimeters. So you can do this with a juice box. You can measure how many centimeters. If you measure a juice box, it should come out to 1,000 centimeters cubed or close enough. So that's a something you can do at home. Might set that for homework. All right. Anyway, let's do this. So this would be kind of like 32 meters. That's quite long. So this could be a pipe in your house, like the hot water pipe. It might be 8 centimeters wide and 32 meters long to get the hot water to your shower. Actually, that's quite a large pipe. That's probably more like your toilet pipe, your sewage pipe. But that's hot water. Anyway, let's work this out. So we got our new diameter formula, so let's use it. And when we're working out the volume of a cylinder, we want to, it's the same as a prism. We want to work out the area of the front face, which is going to be that formula now. But the only thing that's extra is we're multiplying it by the length. So the length is, in this case, 32 meters, which we're going to change to 3,200 centimeters. All right. Okay, so if we put all our numbers into our formula, we are going to get pi times 8 centimeters. 8 centimeters, might just put that in brackets to show I've inserted it, divided by 4, multiplied by 3,200 centimeters. So whenever you're putting things into your formula, you want to have all your units the same. Otherwise, you're not going to get your answer in centimeters cubed. Right. Let us chuck that in our calculator. Shift pi times 8 centimeters squared times 3,200 centimeters divided by 4. All right, and that is 160,800. Whoa, yeah, that's a close one to call. 160,800 centimeters cubed, and that was 4 significant figures. All right, so you could say if you wanted to work this out in liters, then we know that 1 centimeter cubed is 1 milliliter, so 160,800 milliliters. So what would that be in liters? Well, you just divide by 1,000, get it into liters, because there's 1,000 milliliters in a liter. 160.8 liters. That's quite a lot of volume contained in one 32-meter pipe. Okay. Last one, triangular prism. Okay, so this is also an isosceles triangle. So we are going to need to work out the front face of this triangle. So to do that, we need to find our height. So I'm going to draw that triangle, because remember there's 2 equal right angle triangles in there. So one side is going to be 5, because it's evenly split here and here. And the other side, the hypotenuse is 13 meters. And hopefully you might recognize that I've set up a perfect triangle here. But if you wanted to do it just in your calculator, the quickest way is just to go, well, we're doing a short side, so 13 squared minus 5 squared, and so you should end up with 12 when you get out of there, because it's a perfect triangle. All right, we have our height, so let's think about how we could get our front face. We would use half base times height. That would be our front face, and then we want to multiply it by our length that we extrude it. So our volume of our triangle equals half base times height, and then times the length. All right, 0.5 times our base of our triangle is 10, and our height of our triangle is 12, because we worked that out before. And then our length of our, so we got 10 meters times 12 meters times 15 meters. Okay. Sorry, just had a weak mind blank. Put it in the calculator. 0.5 times 10 times 12 times 15. 900. Nice round number. 900 meters cubed. That seems like quite a lot. I suppose that's quite a big, you could imagine this is kind of like a roof space. So the volume of your attic, if you had a huge attic, 10 by 15 is a huge attic. and that angle would be quite a big angle for a roof. Usually roofs are more the other way around, where you got 5 meters that way, and that might be 2 meters, but we had 12 meters, so it's actually quite a large roof space. William just asked, why isn't it just 10 times 12 times 15? That's because we're dealing with a triangle, William, so you've got to remember that half comes into the area of the front face. So this is the area of the front face of the triangle, and this is the extruded length. So each prism has that sort of, why do we half that? You always half a triangle. Triangle is half a box. That's right, a triangle is half of a square. All right. I'm just going to talk about unit conversions, because they can get quite complicated. Well, not complicated, they can get quite different when you do your conversions. So, if this is a box that is 1 meter by 1 meter by 1 meter. So, if I might just do this. So 1 meter times 1 meter times 1 meter equals 1 cubic meter. 1 meter cubed. Sometimes you might hear me say cubic meter. It's just a short form way of saying meters cubed. All right. Now 1 meter, if we wanted to think of that in centimeters, is 100 centimeters times 100 centimeters times 100 centimeters, right? So this is the same box, but we're using centimeters to measure each side now. So we've got 6 zeros now. So 1 cubic meter is equal to 1 million cubic centimeters. All right. So that is the same as 1 million mils, right? So a centimeter cubed is the same as a mil. So that is the same as 1,000 liters. So if you wanted to convert 1 cubic meter into liters, then you have to multiply by 1,000. There's 1,000 liters in 1 cubic meter. All right. Let's think about a massive number. Let's get crazy. This box here that I've got is 1 kilometer cubed. So you'd probably only be using kilometers cubed if you're measuring the volume of mountains, probably. You might say that mountain over there is 5 kilometers cubed. That's a pretty big mountain. But just for the purposes, I want to know how many liters is in a kilometer inside a mountain. So we're going to say this mountain is 1 kilometer cubed. How many liters of water could fill up the inside of this mountain? So I might just leave that problem for 2 minutes, see if anyone can come up with the answer, and then we'll work out what to do from there. And while you're doing that, I might try and find you guys some homework to do. So, homework. These questions are all prisms. While we do that, one last thing. Let's figure out how many liters in a kilometer cubed. All right. Well, we might use this identity as well. 1 cubic meter equals 1,000 liters. So 1 kilometer cubed would be 1,000 meters by 1,000 meters by 1,000 meters. So let's use standard form to do this, because that's just too many zeros for me to write out again. That is going to be 10 to the power of 9. Well, actually, in standard form, we would write 1 times 10 to the power of 9 meters cubed. Cubic meters. All right, and then we've got this identity, 1 cubic meter equals 1,000 liters. So we need to multiply. If we're going to put this into liters, we want to multiply by 1,000. So if we times by 1,000, then that's going to add on 3 more zeros, which is going to bring us up to 1 times 10 to the 12 zeros liters. And fine, I'll write out this number: 1 0 0 0 0 0 0 0 0 0 0 0 0 liters.